I built an app that lets you ask a database anything in plain English. Then I hacked it in 30 seconds with one sentence. Let me show you how I built it, broke it, and fixed it, all with AI agents. Before I write a single line of code, I sit down with Claude Desktop and I explain what I want. I don't ask it to build it for me. I ask it to help me think. I want to build a natural language to SQL app. So Claude gives me a stack with Express backend, PostgreSQL, Haiku for LLM, and the architecture a semantic layer that describes the database to the AI, okay, a query module and a server. So 3 files. All right, let's go. Before I build anything, I want to ask one more thing. What are the security risks of letting an LLM generate SQL from user input? So Claude flags 2 risks: prompt injection, where a user tells the AI to ignore its instructions, and malicious queries, where a perfectly valid SQL reads things and that it shouldn't. Okay, I'm gonna build it first and then we'll see if Claude was right. Okay, the data is already loaded into Postgres. Link in the description if you want the same setup. The data is from the UK government, the Land Registry. Every residential property sale in England and Wales since 1995. 31 million transactions, free to download and open license. So first thing, I need Claude Code to understand the database. I am not gonna tell it what columns exist. I'm going to tell it to find it out. Connect to the PostgreSQL database, inspect the property sales table, read the schema, understand the column types and values, then generate a semantic layer in Markdown that describes the table, what each column means, what the coded values represent, and includes example of natural language queries mapped to SQL. So Claude Code connects, reads the schema, sampled the data, and figures out on its own that D means detached, that F means flats, L means leasehold, and then it writes a semantic layer, a file that explains the database to the AI in plain English. This is what I mean when I talk about agentic development. The agent is autonomous. It explores, it decides, it builds, and that's exactly why we need guardrails. I talked about it in my human.md video, link in the cards. We're gonna be building the query pipeline. So this is gonna be pure functions and test firsts. All right, create a query module with pure functions for the NL to SQL pipeline. Create a build schema prompt function that takes the semantic layer and builds system prompt for Haiku. Validate the SQL should be a function that checks the generated SQL is safe. Only select, no deletion, no modification, nothing. And also we need a strip code fences functions that cleans markdown backticks from LLM output. Write the test first and then implement. Okay, so tests first and the tests are failing. So now it's time to make them pass and make them look green. And this is how I work with Claude Code. I ask it to work with TDD and then I watch and I observe and I control that everything is in place. We are going to ask for the server that connects everything to be implemented. Create Express app server with a post API query endpoint. It receives a question in English, calls Haiku to generate SQL using the semantic layer. It validates the SQL, it executes it against Postgres, calls Haiku again to interpret the results in plain English, and then it should return everything, the question, the SQL, the raw data, and the interpretation. So could you please start the server and copy in my clipboard a curl request with the question, what is the average house price in London? And it works. You type a question in English and it queries 31 million property sales and answers in plain English. But there is a problem. Now I'm going to hack my own app. 2 attacks, both work. The validator only blocks insert, delete, drop, but a select against PG catalog, that's a valid select, and it sails right through, and it just exposed every database user and the password. Remember when Claude Code used the information schema to discover the database? Same tables, but now someone else is reading them. Everything a user types goes straight into the LLM prompt, and everything the LLM generates runs against the database. The only protection is a regex that only looks for forbidden words. That's not enough. The regex catches drop table. It doesn't catch a valid select against your system catalogs, and it definitely doesn't gonna catch a human telling the AI to ignore its instructions. So we're gonna go and fix that with Claude Code. One fix, one prompt, defense in depth. So the NL2 SQL pipeline has a security problem. The regex validator lets through malicious selects against PG catalog and information schema. Implement a new validator using libpg-query, parse the SQL with the real PostgreSQL 17 parser, the AST, and only allow select statements, only allow tables in an explicit allow list. Reject any reference to PG catalog, information schema, PG sleep, PG read file, DB link, and auto inject limit 1000 if missing. Integrate it into the server before SQL execution, and you know the drill. Tests first. So libpg-query is the actual Postgres 17 parser compiled to WebAssembly. This isn't a pattern matching. It's the same code PostgreSQL uses internally to understand. It parses the query into an abstract instance tree, and we walk the tree checking every table reference against an allow list. If it's not in the list, it's rejected. It's no regex. It's no guessing. Both blocked. The LLM can generate whatever SQL it wants. The AST validator won't execute it unless every table is on the allow list. Defense in depth. The regex is the first line, the AST parser is the second. Each layer assumes the one before it failed. Now that it's secure, let's have some fun with 31 million property sales. What is the most expensive house ever sold in England? All right, 160 million pounds. Knightsbridge by the Hyde Park. Nice one. All right, so let's see if we can ask for some hidden gems. Where are the hidden gems? Cheap areas growing fastest. Make it look human readable. There you go. Birkenhead in 2020, 161. All right. What has happened to house prices since 2020? Make it look human readable. And that's the response. 31 million transactions, any question in English, secure, built from scratch with AI agents in one session. Claude Desktop planned it. Claude Code built it. I broke it. Claude Code fixed it from zero to a working, secure, natural language database in one session. This isn't just a demo. If you have a PostgreSQL database, an API key, and an engineering problem, this is what AI agents can do for you right now. Automated property evaluation, investment analysis, any dataset your business already has, made it queryable in plain English. The code is in the description. The data is free. You can build this tonight. Now, I didn't skip the hard parts. Coded, run code reviews on every commit. There was a back and forth, a pull request, and a merge. The full CI pipeline. I covered that entire workflow in episode 2. It's right there. Hi, I am Javi, the LLM Whisperer, 21 years of engineering, now orchestrating AI agents on real projects. If you want to see how that actually works, subscribe, and I'll see you in the next one. Adiós!